Radio 4, it's 8 o'clock and Jeff Watts presents a discussion and phone-in on the 1991 Reith Lectures.
Good evening. The title of the 1991 Reith Lectures, broadcast in November and December of last year, was The Language of the Genes. The lecturer, geneticist Dr. Steve Jones of University College London, used them to outline his view of the current state of the scientific study of inheritance. He explored our understanding of the nature of the genetic blueprint passed on by each generation to its offspring, and the often troubled history of our attempts, well-meaning or otherwise, to exploit that understanding. This evening we want to hear your views, and you can phone us on 071 580 4411. But to begin, a short post-Reithian epilogue from Steve Jones. He recorded it a few days ago and a few miles north of where we are in this studio.
I set the scene for the Reith Lectures in a house a few hundred yards from where I am now, which is a house of a philosopher and scientist, Sigmund Freud, who thought that he could explain the way in which we developed through our lives by referring to the history of human evolution, to what happened in the distant past, to the sort of messages our ancestors had left us. And where I'm standing now is in a graveyard, a big Victorian graveyard, Highgate Cemetery actually, which is in some ways an appropriate place to round off the Reith story, because it's full, naturally, of gravestones which have got statements of common ancestry on them. People keep gravestones, I think, and have family plots, because I think everybody is interested in who their forebears were, where they're buried, and what their history is. I'm standing, in fact, in front of one particularly appropriate grave, which is the grave of a Victorian philosopher called Herbert Spencer. Now, I think everybody knows one thing that Darwin said. Darwin, of course, referred to the survival of the fittest. Well, I'm afraid everybody's wrong. Darwin never said that. The person who coined that phrase was indeed Herbert Spencer, who was a philosopher greatly influenced by the idea that one should apply Darwinism, natural selection, to human life. And he was the founder of what he called social Darwinism, the theme that we should arrange our society according to Darwinian rules, the struggle for existence, the survival of the fittest. Now, that idea, I think, was taken far more seriously than ever he hoped, or perhaps feared. In his own time, Andrew Carnegie, who was then the richest person in the world, the great steel magnate who broke the American unions and had the big steel combine in the United States, Andrew Carnegie himself said that he didn't realize how to run a capitalist economy until he'd read Herbert Spencer, that the answer was to be completely ruthless, and that was quite reasonable because that's what biology told us the way we should behave ought to be. If we take it a little closer to our present day, Adolf Hitler himself was a social Darwinist. The philosophers he was interested in were direct descendants of Herbert Spencer. So it seemed then that Herbert Spencer's view, perhaps, has been used to support the most vicious kind of corporatism, capitalism, and the like. But the story isn't as simple as that. If we turn round, it's another well-known philosopher buried just across the path. A much bigger gravestone with a big, heavy bronze bust on top of it. And that's the grave of Karl Marx. Now, Karl Marx was himself a great follower of Darwin. He actually sent a copy of his book, Das Kapital, to Charles Darwin, and I'm glad to say it was found unopened and unread after Darwin's death. Marx felt that what Darwin told us was that society should be arranged in a socialist kind of fashion. And he actually said to Engels that Darwin proves the scientific basis of what we call scientific socialism. So here we've got three different philosophers. Freud feels that biology drives our lives in one way. Spencer feels that biology, genes, evolution makes capitalism the best possible, the natural kind of fashion in which to organize society. And Karl Marx goes exactly the opposite way and says that genes, biology, history, and evolution all conspire to prove that socialism is right. And in some ways that perhaps summarizes the kind of theme I've tried to explore during the Reith Lectures. They're, in some senses, the limits of science. The fact that genetics can tell us a great deal about the past, but can tell us, I think, rather little about the future. And that's what I hope we're going to be able to discuss this evening.
Well, as Steve Jones has just reminded us, he was as keen in his lectures to stress the limitations of genetics as he was to underline its possibilities, as keen to say what it can't tell us about ourselves as what it can. But as I'm sure, I suspect, he'd agree, it's always possibilities rather than limitations which capture the imagination. The most recent translation of genetics into popular drama gave us the television adaptation of Fay Weldon's novel The Cloning of Joanna May, which was a triumph of scientific plausibility by comparison with the more usual stuff in this field about recreating Hitler or breeding races of supermen. To identify the more realistic and certainly more immediate consequences of modern genetics, You have only to think of a handful of by now familiar terms: genetic manipulation, gene therapy, genetic screening, genetic fingerprinting, and so on. Each has raised a new tangle of legal and ethical dilemmas, some of which I'll be discussing with Steve Jones and with three other people here in the studio. They are Honora O'Neill, Professor of Philosophy at the University of Essex and shortly to become Principal of Newnham College, Cambridge; Lewis Walpert, Professor of Biology at the University College and Middlesex School of Medicine; and John Maynard Smith, Professor of Biology at the University of Sussex. And don't forget, most important, we also want to hear your views on genetics and the fears or hopes you have in connection with its practical application. Ring us on 071 580 4411. The number again, 071 580 4411. Steve Jones, let me begin with you, if I may, and on a very general issue. You pointed out many times in your lectures that geneticists of a previous era didn't really recognize what you see as the appropriate limits to their subjects. Their pronouncements are now seen as unjustifiable, but of course they were men of their own time. Now, in our time, it could be said there is a new kind of liberal orthodoxy, often referred to, I think, in its most extreme form now as political correctness, which tends to take a very dim view of speculating about the role of genetics in matters such as gender and racial difference, IQ, and so on. I wonder if you couldn't be accused of having gone too far in the opposite direction to your predecessors. In other words, you've perhaps underplayed the importance of heredity as a determinant in our relationships and our behaviour. Do you think you've gone too far the other way?
Naturally, of course, as you can predict, the answer is no. Because if I thought I'd gone too far the other way, I wouldn't have said what I said. My views are liberal views, in fact, they're socialist views. I like to think that that has nothing whatsoever to do with my views of genetics. My political views and my genetical views, I like to think, are independent things. And I would be depressed to feel that people perceived what I said in the Reith lectures as being driven by the way I vote. I see them as independent operations. And that, I like to think, is what most biologists feel about their own views. I know that around this table there are people of very different political views. Our views of genetics, I hope, are similar and are not being altered by the way in which we perceive ourselves as being politically correct, to use that rather facile and trivial phrase, or politically incorrect. The two things are independent entities, independent operations, and I would like to hope that they would remain that way.
You wouldn't feel that if you wanted to pursue certain genetical lines of inquiry that you would come under a certain amount of pressure to withdraw from them? I mean, I'm thinking the most extreme example, the one we've heard about many times, of course, is Professor Hans Eysenck, the troubles that he has had at various times in the past.
The trouble with many people who feel themselves as being persecuted because of their political views is that they're scientifically wrong. And the trouble with Eysenck is that he's wrong.
That's straightforward, anyway. John Maynard Smith, what do you think about the general tenor of the lectures as Steve Jones presented them? Do you feel that he has underplayed the significance of genetics in these respects, or do you think he's got it about right?
Yeah, I think he got it about right, but I have to say, I think he's a little sanguine in thinking that our views on the relevance of genetics are unaffected by the political world around us. I mean, I'm a good deal older than Steve. When I was young, it was before Hitler came to power in Germany, and eugenic ideas were very popular, and I shared them to some extent. I was only a schoolboy, but it seemed to me that genetic deterministic ideas were fine. It was very striking the way that it was really only after Hitler's coming to power and the spread of Nazi race theories in Europe that geneticists suddenly started turning around and saying, look, we're really not as clever as all that. It's not such a good idea to sterilize everybody in sight because there's something wrong with them. It was very dramatic, in fact, the way that geneticists suddenly started talking sense in response and in hostility to Hitler, because before that they had been talking the most unutterable rubbish. So I think we shouldn't be too sure that we're uninfluenced by our political environment.
Honora O'Neill, are you aware, not obviously in this particular field, since you are a philosopher, not a geneticist, but aware of a possibility of this happening within academia, that certain lines of inquiry are frowned upon because they happen not to fit with the fashionable intellectual thinking of the times?
I'm sure that goes on in general ways, but in this particular case I'd have thought one would be much more worried about the question of whether certain commercial interests might drive directions of research rather than questions of political correctness. This is, after all, a field in which there are vast fortunes at stake if biotechnology achieves things that some people would like to achieve. So I'd look more specifically to that sort of pressure than to political pressures.
Lewis Walbert, you are not a geneticist, but you are a biologist, and therefore you are informed of these matters, but take a slightly more detached view. What did you think about the extent to which Steve Jones was suggesting that genetics did and didn't play significantly in our lives?
I think he somewhat underestimated the role that genetics plays in our lives. And if I could take a sensitive area, something like the difference between male and female, as a developmental biologist, I would find it very surprising if there weren't fundamental differences between males and females in their brains, in their attitudes, and their behavior that weren't genetically determined. Now, I don't think that's a politically acceptable or correct view at the moment, but I would be very surprised if it wasn't the case.
Steve?
You'll notice I didn't discuss that question at all during the Reiths.
Now why not?
Because first of all, because it wasn't the theme which I was talking about.
No.
I agree with Lewis Walbert. It's clearly the case that there are genetic differences between males and females. To pretend that that's something startling and new is to show an astonishing arrogance. I mean, that's known to most 5-year-olds, I would say.
But would you accept that you might perhaps possibly face difficulty if you wanted to pursue lines of inquiry in that direction?
I wouldn't.
Others possibly of equal standing to you might.
A fairly humble standing, I think I'm taking. Not at all. I don't see that at all. I mean, there are... The thing I find strange about the public perception of genetics is the way, to me, that the public, the letters I've had, and there be many, concentrate on what are the most boring issues of genetics, the most unanswerable, the most tedious, the most murky.
But to many people, most fundamental, perhaps.
Well, I feel they're wrong. They're murky questions about why are men more aggressive than women? Why do people who have why do intelligent people have intelligent children? Those to me are far, far less interesting than the deeper questions about genetics, which are the molecular questions. Why do we develop the way we are? What are we related to among the peoples of the world? What's our historical relationship to other primates? These are answerable questions. It's a strange thing about genetics. It's a bit like, I suppose, astrology. Many people concentrate on the unanswerable, and it's the nature of science that it is only interested in the answerable. And vague questions about social attitudes and political correctness are unanswerable. I mean, they have nothing to do with genetics, and that's why I didn't really concentrate on them.
Well, let's see what our first caller has got to say, or to ask us. It's Dennis Barbour, calling us from Buckinghamshire. Now, go ahead, please, Mr. Barbour.
Thank you very much. I'd like to ask Steve Jones, as I'm an amateur genealogist, what can genetics tell a genealogist? I've traced my family history back in parts to 1620 from written records, some living memory. I've had to interpret records, make deductions. Can I get some interesting and accurate information from the genes of myself and my family?
Well, there you are, Steve. That might be a way of raising a little extra cash for your department if you could find a commercial application like this. I mean, is there any bearing that genetics can have on this kind of very practical idea?
Well, practical questions are, my God, we need extra cash. The answer is, of course, yes. I mean, the first geneticists were the College of Heralds. They were obsessed by the idea of common descent, who was related to whom, and they kept very good records. That's why the royal family is, in fact, a very, very useful and valuable part of British life, because they are a natural genetic experiment, a laboratory in which we can have long, sensible genealogies which we can look at, which have told us a lot. And your caller is right. If he were able to look at the genes of those people he perceives to be his relatives, then that would tell him a lot about their common ancestors. If he were able to dig up one of his ancestors, which I hope he isn't tempted to do, the new genetic technology of looking at fossil DNA might be able to tell him a lot more. So, genealogists are geneticists. We're working in the same field. Our field is probably less romantic than his, but we're basically doing the same thing.
John Maynard Smith, I mean, there is an enormous interest now, as we know, in the Human Genome Project, in the attempt, really, to actually unravel the complete genetic structure of man. I mean, obviously, this is not the reason for it, and this is very far-fetched, but can you imagine that, given that kind of information, then people like our Mr. Barbour from Buckinghamshire would actually be able to learn something?
Well, I think the Human Genome Project is rather a different issue. I mean, I think it's largely a nonsense, actually. It's a very expensive one. But the interesting thing from the point of view of the genealogical question is that it's much easier to detect female ancestry than male ancestry. I mean, genealogists tend to be obsessed with the male line, but it's much easier to trace the female line because there are some genes which are only transmitted through the female line. So what he really wants to do is to look at all his female relatives, beg a little blood out of them, and get going on that, and he'll get a beautiful female genealogy.
Well, that's one useful piece of practical advice. Lewis Walpert, anything to add?
I just want to sort of defend the Human Genome Project at some stage, perhaps not at this one, but I can't let it pass just like that.
Okay, we may well come back to that. Well, is that of some help, Mr. Barbour, if you're still there?
Yes, it's very interesting. I would hope that perhaps we might get Dr. Jones to talk at one of the Society of Genealogists conferences one year.
That is indeed a possibility. Right, perhaps this would be the moment, actually, to say a word about the Human Genome Project. First of all, let's have its detractor. Why so much a waste of money? First of all, remind us exactly what the Human Genome Project is supposed to do, to achieve, John Maynard Smith.
Well, the Human Genome Project, in theory, is supposed to supply us with the sequence of the human genome. That's something like 10 to the 9th basis. It will go A, C, T, 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 G, 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 and it'll go on doing that for hour after hour after hour. It is hard to imagine a more boring enterprise than either collecting it or reading it when it was collected.
It's a vast code, essentially, a large number of these 4 letters arranged in certain sequences.
Its great virtue, as far as I can see, it is the kind of idea that you can hope to explain to an American senator. And therefore, you can hope to get a very large sum of money for it. And scientists love money, and given that there's lots of lovely lolly going for doing this, all the people other than me, I'm too old to mind, who are in genetics are saying, oh, I think it's a great idea because I'll get my hands on some of this lovely lolly. It's very far from clear to me that the information when collected will be of the least interest to anybody. And it's perfectly clear to me that the one thing I do not want to have to do is to collect it. It is mind-boring.
Lewis Walpert, before you erupt, I mean, you obviously don't feel this. Well, why do you think it is worthwhile having this information, which John Maynard Smith regards as so uninteresting?
Well, also, and Steve Jones in his lecture thought it would be very boring, but it's boring in the sense that somebody who reads a Polish novel and doesn't understand Polish would find it boring. It's terribly interesting to somebody who knows how to read that code. And first of all, there are 2 aspects to it. First of all, that mapping many of the genes before you get down to the fine detail, knowing where many of these important genes related to health matters will be terribly important.
But we could say we're getting that now, just bit by bit. We don't need the whole lot, do we?
No, you don't need the whole lot, but the more you have, the better. Secondly, a lot of this boring work will be done by machines, and John hasn't got to do it, and Steve doesn't have to do it. Machines, hopefully, will do a great deal of this. And secondly, it's going to tell us a great deal about, we hope, about cells. For example, one of the projects of the Genome Project is to sequence the genome, the genes, all the genes in a little worm, the nematode worm. When we know that, we'll be able to really tell us something about every protein that is made in a cell. Now that will be a monumental possibility, to really have a list of every protein that is required in a living cell. I think would be absolutely tremendous.
We will actually understand the way that cells work better than we do now.
It will help. No, it won't immediately. Reading this book will need quite a lot of translation, but it's certainly a jolly good beginning.
Steve, you were perhaps slightly sympathetic towards it in your lectures. I mean, you said it was expensive, then said, well, it was only the cost of one Trident submarine, so it's well within our capacity to buy this information if we want it. On balance, you think it is worth going ahead and doing this, do you?
On balance, I'm forced to say yes. Tedious but necessary.
Well, looks like John Maynard Smith, you were outvoted 2-1. Very, very quick response. Are you going to change your mind?
It is simply not true that when you know what the sequence of this thing is, you will know what proteins the organism can make. You do not know how proteins fold up. You don't know, even if you did, what they would do. It's like issuing Newton with a machine code for how to make a television set. Newton was very smart, but he wouldn't have understood a word of it. We are very smart, but we will not understand a word of it.
OK, well, it's all going to be there anyway, within the next decade and a half or so, though, then we'll know who's right and who's wrong. Let's go to our next caller now, Mike Stevenson from Stroud in Gloucestershire, who is going to take us away from pure science and into other matters, I think. Go ahead, please, Mr. Stevenson.
Yes, I didn't want to take you away from anything. I'm enjoying the programme, as I enjoyed Stephen's lectures on the language of the genes. I also enjoyed Richard Dawkins' lectures on the Christmas lectures for children. From
the Royal Institution ones.
Yes, the Royal Institution lectures. And it seemed to me that some of the arguments in Stephen Jones's lectures concerning evolution heading in the direction of selection of species rather than selection at the genetic level, because, for example, in one of the lectures he gave, he described farming spreading across Europe, and in fact somehow it was the social structure that was determining what happened to the genes. would he agree that this is a correct understanding? And if so, would it seem that this flies in the face of more commonly accepted genetic selection, that is, selection at the level of the gene?
Steve Jones.
Yes, I think in some ways this summarises my own view, and I think many biologists' views, that when we're talking about human evolution, we have to bring in rules which don't apply quite as simply to animal evolution. It's clearly the case, if you look at the patterns of genes among the human populations of the world, that they have generally been driven by social advance. Right? The case your question, your caller mentions, is the fact that there is a clear trend, genetic trend across Europe, which we can relate quite well to the fact that the farmers, who grew enormously in number, spread from the southeast to the northwest of Europe. And we can see that again and again. And that clearly is that there's been an economic change which has led to local population growth and the spread of particular genetic types at the expense of others. It's harder to see in the sort of thing which Darwin would have talked about, an economic, a social change leading to genetic advance of that kind. So I think it tells us that human evolution works to the same principles as animal evolution, but we have overwhelmingly to take into account the fact that humans are driven by culture and economics to an extent which animals simply are not.
So it's the same, but more complicated, as it were, with other factors which are bearing in to a greater extent than in animal evolution.
It's hard to know which we understand less, human evolution or animal evolution. We scarcely understand either of them, and we can use one to obscure the other, and that's what I hope I'm trying to do during the lectures.
John Maynard Smith.
No, I have no comment. I agree that he obscured everything.
But you mean that in the nicest possible sense. Let's move on very rapidly to our next caller, who is Winston Crossland, calling from Oxfordshire, who is going to take us even further away from pure science, I think. Go ahead, please, Winston Crossland.
Well, I don't know if it's away from pure science. I heard a program the other day which said that there are genetic connections between Neanderthal man and European man, but not between Neanderthal man and African man. And this tended to disprove the Eve theory of a common ancestry to the whole of the human race. And I would just like to hear Dr. Reith's comments on that.
Right, let's unravel that bit by bit. First of all, the Eve theory, Steve Jones, what is that?
Well, the Eve theory is the idea, which is supported, generally speaking, by fossils, and has some genetical evidence in favour of it, that the common ancestor of all humans in the world was probably lived in Africa. The Eve theory is a triumph of form over content in some ways, because a great fuss was made of the fact that we can trace each one of us in the world, our ancestry back to one woman. Now, fair enough, we can, of course, do that, but it doesn't mean to say by any means that that was the only woman alive at the only time, at that particular time. If you believe the Eve theory, the Garden of Eden must have been an extremely crowded place. There are probably hundreds of thousands of Eves in it, only one of whom's genes have survived. I think your caller's a bit confused. Perhaps the program he listened to was a bit obscure about the relationship between Neanderthals and the rest of the world's present population. The modern view, and these things change because it's a rapidly changing, evolution is a rapidly changing subject, is that there was a subgroup of of Homo sapiens, the species to which most of us came to belong, which moved to Europe and the Middle East from Africa. That was the Neanderthal humans. They flourished for a long time. They had a jolly time. They didn't change much. They obviously enjoyed life as it was because they scarcely altered in 200,000 years. It then looks, from what we now know, that they went extinct and were actually replaced by another wave of modern humans who emerged from Africa. So as far as we're now aware, there are no Neanderthal genes living in any of the living populations of the world.
Is that a summary that you would find acceptable, John Maynard Smith?
Well, I can only report last Sunday's newspapers, which is where I get my science from. Someone in the AAA, the American Academy...
American Association of the Advancement of Science.
That's the one.
Yes, the annual meeting.
Claimed, and I've no reason to doubt it, to have got hold of a hand axe made by a Neanderthal man or woman, we shall soon know which has got some blood on it and some sawdust. So they were obviously whittling a piece of wood and cut their finger, bled all over it. Now, nowadays, molecular data is such that before very long we will know not only was it a man or a woman, but we will be able to ask just how closely related were these guys to us. And I think I'm longing to know the answer. Fairly soon.
Keep reading the Sunday papers, I suppose, is one solution to that, isn't it? To John Cole in Devon, who's calling us now with a question about intelligence. Let's have John Cole.
Yes, I have a question about the evolution of human intelligence. Surely every kind of animal would survive better if it were more intelligent. So I wonder if there's any clue, either in the genetic record or anywhere else, as to why we particularly should have been selectively bred for intelligence.
Why are we so clever, Steve?
Well, speak for yourself.
I was. I include you in this thing. It does mark us out, doesn't it? I mean, when you compare our species with virtually every other, we have made rather something of this notion of intelligence and exploited it.
I see you have no chips around this table. I mean, if although looking around the table, I think there's a certain anthropocentrism here. You know, I mean, if we were dogs, then we would be very, very depressed by how stupid we were at perceiving the world because we couldn't smell it. So in some ways, it's a statement, you know, the question of intelligence is really a very woolly one, which is hard to grasp at.
I suppose perhaps it's something to do with control of everything around us, the planet, the environment. We have taken control uniquely among the species on this planet, in fact, to the detriment of many of the species on this planet, haven't we? So in that sense, we are different.
Yes, the same could be said of the malaria parasite. I mean, that's taken control of many creatures. I mean, this is a philosophical question rather than a biological one.
Lewis Walford.
Now, I think it is about control. It's about tool using. It's about being able to actually alter the environment in the way that you want to. I think a major characteristic of humans is their ability to use tools and to sort of develop some sort of technology. And I think not all of intelligence, but a certain kind of intelligence is required for that.
Nora O'Neill, I mean, putting aside the questions of biology and looking at it purely as a philosopher, I mean, do you make a distinction between the kind of success our species has had on this planet and the kind of success which, for example, Steve Jones says the malaria parasite has? I mean, intuitively, I feel it's ridiculous to compare us with malaria parasites.
I agree with you.
Well, can you, I mean...
You have a biased view.
Right outside of biology, do you feel that it's ridiculous to make that comparison?
I doubt it's a very philosophical thought, but it seems to me that intelligence is really an enormous diversity of different abilities, and we're very, very good at some things, but I agree with Steve. We may be a good deal less aware of the ones we're not so good at, like smelling or navigating. And the things that make us really distinctive, the things that give us that particular sort of control, are surely connected with capacities for communication and elaborating systems of communication. Would it alter the question, Steve, if one looked at that particular facet of intelligence, let's call it, which has to do with language and communication?
I think it probably would. I mean, the problem with the word intelligence, and here I speak from a complete layperson's view, a view of utter ignorance, is I don't know what people mean by intelligence. Now, people like Hans Eysenck do know. I don't. I wish they'd explain to us in words of one syllable.
Yeah, but I think you can it's like this whole thing about an elephant, isn't it? When it was first said, you can't describe it, but you know one when you see it. And I think probably most people, not looking at it perhaps philosophically or scientifically, but most people on an everyday level do feel that they can identify something called intelligence. And and we have it, our species has it uniquely.
That strikes me as an impressively anti-scientific view.
Well, I did say this was not necessarily a scientific or a philosophical view. However, let us move rapidly on to Dr. Aubrey Sandman, who's calling us from London. What is it you want to ask or say, Dr. Sandman?
Hello. It's really quite simple. People with severe genetic defects are now mercifully, and I say this with feeling, are mercifully surviving, who before have died, and they're reproducing. And I estimate that in probably about 500 years' time, very few of us will be around who are not suffering from some severe genetic disease. Now, as things stand, there's a great body of opinion which says we mustn't operate directly on the gene pool. Do you think this is going to be sustainable in, say, another 50 years' time when this becomes something that we will all be able to notice? Thank you.
Well, thank you, Dr. Sam. Well, I don't know. Thank you. You've painted a rather gloomy prospect for us. John Maynard Smith, is this correct? Do we have this thing to worry about?
Well, let me say, first of all, that I sympathise with the questioner because I suffer from a degree of myopia which would have ensured that I was starved if I had belonged to a hunter-gatherer society, and I'm jolly glad that people invented spectacles and enabled me to survive. But if you do the sums, it's not going to be 500 years, it's going to be more like sort of 50,000 years before the increase in the frequency of bad genes results from our taking trouble to prevent people from dying of myopia or of whatever it may be. So I'm not worried. My own view is that if we can cure a genetic defect, we should be delighted and we should do it. then by the time it becomes serious, in a population sense, 50 years, 100 years, 500 years, 1,000 years, okay, so we'll change the genes. We'll know how to, and we'll be confident to do so. So I'm not worried about this particular problem.
It seems to me, John Maynard-Smith, that you've sidestepped the ethical issue by raising one and said it doesn't matter in practical terms. Honora O'Neill, do you think there is an ethical problem here?
There's surely a question about how far people with genetic defects will in fact pass them on. And the genetic defects that most worry us in human terms are the very ones that make people least likely to pass them on. But granted, we all have genes we perhaps would sooner not have for myopia or for things that are much worse. It seems to me that this is why one needs to look at the question of gene therapy, and I'm not any sort of expert here, but surely that is something that should give us a bit of hope that things that throughout history have been sources of great misery for people may in some cases be able to, through the sort of knowledge that is now accumulating, actually corrected. And that's not talking about that's not talking about genetic engineering, just about ordinary medical intervention for people who are afflicted.
But at the moment, it does tend to make people rather nervous, doesn't it? The notion gene therapy, people say, oh, we must be careful, we must regulate this. And I think probably people are more worried than they are hopeful of notions like gene therapy at the moment.
Well, there are some forms of gene therapy, aren't there, which are quite standard and we don't even recognize as gene therapy. For example, the special diet that some infants are put on because they have PKU, and I can't remember what those initials stand for, but that's a genetic deficiency that is medically treated by putting the child on a special diet until adolescence. That's not an alarming thing. It's something that was found out before recent advances in genetic knowledge. But there are things like that which are quite unthreatening.
Perhaps that's more compensating for the gene defect rather than actually altering the gene defect. And it's when people are probably wanting to introduce new genes or to do something to the genes themselves rather than just compensate. That's when the problems start to rise. Lewis Walpert.
Yes, I want to pick up a remark that you made right at the beginning of the programme, saying that Fay Weldon's play about cloning was quite plausible.
No, I said by comparison, Lewis. By comparison with
yes, well,
dreaming of recreating Hitler, it was scientifically plausible.
No, I think it's about as implausible. You see, I think a great deal of these anxieties about genetic engineering really come from people who know absolutely nothing about it. And it's a curious feature that genetic engineering has really, as far as I know, never done any damage to anybody.
Well, let's take you up on that, because right now on the line we've got Sybil McColgan, I think it's pronounced, from Ludlow in Shropshire, who wants to know precisely that question about scared of genetic engineering. Is that right? You feel people are scared?
Yes, I think people associate it with sort of Hitler and Dr. Mengele, whatever his name was, that chap that was in The Boys from Brazil. I think it's essential that we should understand our genes. I thoroughly agree with the last caller, because the point is, if you're going to turn people back into the population who have birth defects and things like that, and heaven knows, I mean, if it were my child, I would want it saved. I mean, I'm not in any way suggesting that shouldn't be so. You're weakening, surely, the genetic stock of humankind. And the only solution is to understand the genes so that you can remove the weaknesses literally forever from that person.
It's implicit in what you're saying that you don't feel that genetic engineering is something to be scared of, then you're happy with the idea?
Oh yes, providing it's not... there's a difference between knowing about the genes and taking away horrible genetic diseases from people and birth defects and things like that. There's a great difference between that and deciding that you want a fair-haired child that's good at music, if we ever get to that stage. I mean, the one is undesirable and the other is, I would have thought, extremely desirable.
Honora O'Neill, we were talking just now about gene therapy and making people nervous. Genetic engineering, I mean, the term is a very loose one. That does make people even more nervous, doesn't it? I mean, our caller, Sybil McColgan, is quite right.
In some ways, I think we should think about more familiar things like selective breeding, which, after all, have produced changes in certain other species, plants and animals, and not immediately run to the thought that there could be interventions which are highly sensational and frightening. And the thing that I found so impressive about Steve's lectures was the way he explained the genetic system as a range of information as a code, maybe an extraordinarily dull code, but with very exciting potentials if read. And I think that the things that we might really be worried about for their ethical implications are less to do with the nightmares of people engineering either monsters or supermen and women than with the question of what difference will it make to our lives if we know so much more about our genetic background, so that for me the real ethical problems lie in the area of genetic screening rather than genetic engineering.
Is it your feeling that programs like, I don't know whether anyone else around the table actually saw it, Faye Weldon's The Cloning of Joanna May, do a disservice to people? Or you didn't see it?
I didn't see it.
Well, clearly, Lewis Walpole, I presume you did.
No, I certainly didn't.
Oh.
I would have been too enraged.
You speak from divine understanding of this, well, obviously.
Well, no, but the very fact that you have a phrase like a cloning of Joanna May, is just full of phoniness. It's using science and...
Steve, did you see the cloning of Joanna May?
I did.
And did you think that it did a service to the notion of what is possible using these kind of applications of genetics?
I think I could have found 4 actresses who looked more similar than the 4 alleged clones of Joanna May. It is, let's be frank about it, it is potentially possible. The word clone has a precise meaning, which I think was wrongly used there.
Yeah, she was using it loosely.
But it is potentially possible to produce numbers of identical twins who are in fact clones, one from the other. My response to that is, so what? As it happens, my mother is an identical twin. I'm not sure that's changed my life. I'm not sure it's changed hers. So most of the experiments which are claimed to be horrifying have in fact happened in nature already. The whole of medicine is genetic engineering. All the way public health is genetic engineering. When you control malaria, you will alter for certain the genetic future of the human being. A particular gene, the sickle cell gene, which evolved to protect malaria, will now lose its advantage, so those populations will change genetically. And as I say, my answer is, so what?
Right. On to Neil Brooks in Brixham in Devon, who has got a very practical question for us, I think. Go ahead, please, Mr. Brooks.
Yes, I'd like to bring you down to earth a little bit.
Only a little bit.
Well, perhaps a lot. My daughter has cystic fibrosis, and my question was simply based on a news story which I heard some weeks ago, where it seemed to me that a genetic breakthrough had come across with the cure of cystic fibrosis, but I had no idea really what was going on, and I wondered if you could clarify it for me.
Yes, Steve Jones, what exactly is happening at the moment in cystic fibrosis?
I think the first thing I have to say is that I'm not a doctor, so I can't talk with any confidence about matters which are clinical. I'm sure that your doctor and the people who are involved in the care of your daughter are far more qualified to say this than I am. The disease cystic fibrosis, as I'm sure you know, and many of your listeners the other listeners will know, is the most common inborn error among peoples of Western origin, of European origin. It is in some ways, at the moment, a scientific triumph that they have tracked down, the geneticists have tracked down the gene which is responsible for the terrible disease, cystic fibrosis. At the moment, it's a scientific triumph. It shows hope, and its only hope, that it may become, and I think may is the important word, it may become a clinical, a medical triumph. It would take a long time to explain how the work was actually done, but by using the techniques of modern genetics, geneticists have tracked down the actual genetic defect which is responsible for the disease. From tracking that down, they've managed to work out what the gene must actually do, what its function is, what it looks like. Based on that work, there is the beginnings of a hope that it may be possible to generate in the laboratory a protein which replaces the defective protein in those suffering from the disease. And there are the very beginnings of a treatment which may allow children with the disease to inhale an aerosol which contains the corrected protein, and it may help them cope with the symptoms of the disease. And it is a symptomatic treatment, and that's all it is. It's like many other symptomatic treatments. But the hope is there. It would be wrong of me to say that a cure is available, because it's not. But there is the long-term hope of a cure, which has come, I think, from human genetics.
And inhalation, because that would take it exactly where we want to solve the problem, which is in the airways leading down to the lungs.
Yes, in principle, the treatment is exactly the same as primaquine is the treatment for malaria. It controls the symptoms of the disease. It does not cure the disease, but of course medicine doesn't generally cure things. It alleviates symptoms.
And you've got to keep on repeating this, possibly over periodically.
Oh, I think most certainly, yes.
Honora O'Neill, I introduced you as a philosopher, but of course you are also a member of the Nuffield Council on Bioethics. Perhaps you should actually say briefly what that is, because it's still a relatively new body, isn't it? About a year, 18 months.
That, even less than that, but it's a body established by the Nuffield Foundation because there is no national bioethics body in this country. We've had a whole lot of committees that have looked at particular problems, for example, the Warnock Committee, but also many other committees. And the new biology, including above all the new genetics, are of course throwing up a whole set of problems for which we have to have a certain response, which is complicated, not just medically and clinically, but also socially and ethically. And this council's charged with, not with doing the work, but with trying to work out an agenda for which problems should be treated next. And at the moment, one of the things that they're going to be looking at is genetic screening, and they have a working party that's going to do that and is going to try to work out what implications the sorts of information that could, in principle, perhaps become available would have for quite ordinary things like insurance or buying annuities, or how they might be used if they got into the wrong hands to discriminate against people in employment. And these are very ordinary, but I think vital things for all of us.
What about gene therapy? Is that also on your agenda?
No, it isn't at present, because other committees have looked at part of that issue, and it may come onto the agenda at some future time, but at the moment it's genetic screening and the use of human tissue in medical and scientific contexts.
You made a very brief passing reference there to insurance. What are your worries specifically about genetic screening in relation to medical insurance?
The worry is supposedly this, that by finding out a great deal more about our genes, we also find a great deal more about the risks that each of us has for suffering from certain sorts of things, the sorts of things that our insurance companies would dearly like to know before they issue us with a life insurance policy. And if it's true, and this is something that I'm not at all clear about, that it would be possible to divide the population up in a much more accurate way into a whole different set of groups, perhaps hundreds and hundreds of groups for whom the risk is different, it would then be commercially sensible for companies to offer different premiums. People would have to pay different amounts for the same insurance. Now, eventually, if you pushed that forward, it would undercut the very principle of insurance, which is that of pooling risks among us.
And so this could be discriminatory in some ways, because it might not only be more expensive for people with certain patterns of the genome to get insurance, but it might be impossible, possibly for some who were destined, it would appear, from their genetic inheritance to develop such and such a disease in such and such a distant time.
That looks like being the worst side of it. I mean, at the moment we have to note that already we get different insurance rates if, for example, we're smokers from the ones we get if we're non-smokers for certain purposes. But this is in a way different because there's no element that's voluntary in somebody's having the genes they have, whereas it might be said that if I choose to smoke and then have to pay more for my life insurance, well, that is already a choice I've made. On the other hand, on the other side of the question, doctors will already ask something about your medical history, and the life insurance company will look at that record when issuing you with a policy.
Lewis Wampert, is this something you're worried about?
Well, I think it's a problem, but isn't it true of car insurance? Whether if you're young and you want to drive a fast car, it's extremely expensive. I mean, there's already discrimination in many areas of insurance.
But isn't it a question of choice, that you choose your car,
you can't
but
choose
you don't
your
choose
age.
your genes?
You can't choose your age.
Well, let's see if we can get someone to arbitrate on this. Dr. Mary Reynolds is on the line. Dr. Reynolds, you're chairman of the Medical Affairs Committee of the Association of British Insurers. Now, I can't imagine that you haven't contemplated and perhaps agonised, well, at least I hope you've agonised over these issues already. Would that be true?
That's absolutely true. I think the insurance industry, we are in a formulative phase at the moment, indeed, keeping up with the scientists. And what I would like to reassure any listeners is that we do not see the genetic problem coming really into an underwriting way for some years. So by that time, the Association of British Insurers will have formulated a code of practice. We will indeed be talking with the Nuffield Council, physicians, scientists, all involved, so that when you're breaking medical and ethical frontiers, we will adopt a moral, logical, and equitable approach. But I think we must take up some points. That doesn't mean to say that this is all going to go away. Professor O'Neill mentioned the medical history. Well, genetic disease and mapping of disease, predictability of disease, this may well in time redefine our whole format of disease. Now, when ECGs came around, mammograms, cervical smears, chest x-rays, medicine didn't stop and say for fear of getting an insurance policy. We have to get our priorities right and not fabricate unnecessary fears. What certainly the industry will do is keep the public with us, and never, even in the long-distant future, will we be using tests that depend on probably might or if environmental conditions. These tests would have to be 100% accurate, absolute in predictability, in the same way as we classify disease now with reason and knowledge. In the main, the more knowledge we have, it's not less will get life insurance, it's in fact more. Many listeners will go back 20, 30 years and know that the insurance industry never took on severe impaired lives such as heart disease, diabetes, you name it. You had to be fairly healthy. Now, with more and more knowledge, more tools at our arm, we can be braver, we can get the assessment more accurate. There will be losers and winners, of course, to some degree.
Hang on a minute there, Dr. Rance. Let's see if Honora O'Neill is actually persuaded of this, that the industry is taking these matters seriously and will take account of such information, such far distant tests of our genetic inheritance when they become available. Are you happy about this?
I'm sure the industry is taking it seriously because it will alter a great deal of the context in which the industry is working. I think that going beyond the concerns of the industry, we also have to reckon that if there is this large additional amount of information, it is, of course, information that people will not want readily available to their insurers, perhaps, or perhaps to other parties. And the control of this information will, I think, be a large part of what the working party of the Nuffield Council that's dealing with genetic screening has to look at. How can we prevent this information getting out into hands where it shouldn't get?
What would the wrong hands be in this instance?
I imagine that it could be very close to home. It could be the case that you wouldn't want all your relatives to know about your genetic profile. You maybe wouldn't even want to know yourself. We have already discussed on the Council the question of whether there are some things one would sooner not know about one's future life. For example, many couples now, even if they have amniocentesis, choose not to be told the sex of the child they're going to have. And in the same way, I can imagine that there could be many contexts in which people would say, well, I realize I may have some acute problems ahead, but I don't think my life would be helped by knowing that.
Steve Jones, are you worried about the extent to which we're becoming clever in this field?
The thing which impresses me for the last few minutes' discussion is what an overwhelming case it's made for a national health service. Because if there was not a national health service which gives everybody the same chance of being treated, then every time we treated a patient, we'd be making this argument. It's their fault, it's their genes, there's no point in treating them. Of course, if we were listening to an American audience, if we have an American caller, this is precisely what would be happening. You're a sickle cell carrier, therefore you're more expensive to insure. This is the best case I've heard for many years for a genuinely state-funded health service.
Yes, it's a case of pooling risk, isn't it, Nora O'Neill?
Yes, and I think it is having just that impact in the United States, where there are 400 different providers of commercially based medical insurance, very expensive too, and not something all Americans have. 35 million of them lack it totally and are not covered by any of their schemes. I feel that you cannot run a commercial system of medical insurance in the face of this sort of knowledge, because you've got to say at a certain point, well, we're going to disregard some information even though we know that it is information that tells us that these two people have radically different risks.
Before we pass on, can we just take one step back a minute? We keep on talking about the problems and hazards of the knowledge that we accumulate so successfully. Steve Jones, as a geneticist, one of the people whose profession it is to accumulate this particular scientific knowledge, do you feel that your profession should have any specific responsibility for the uses that are made of this knowledge, or do you stand in relation to it just as everyone else does, as we hope a responsible citizen?
I often thought that to blame scientists for the use that's made for their research is like blaming a barometer for the weather, right? for the trivial things I've done, we discover things. What's made of those discoveries is a societal decision. And I've always felt that's particularly true for genetics. I mean, a thing like a matter of whether there should or should not be, as we've just been saying, a national rather than a private health service is not a genetical question, it's a moral question.
Yes, now,
and I've said that again and again, and I believe it very strongly.
But I can just imagine people all over the country leaping back and saying, no, come on, that you are one of the people who's actually digging this knowledge out. Can you really so easily divorce yourself from it as that and say, all right, it's my responsibility, it's my job to dig out the knowledge, it's the responsibility of others to use it? Lewis Wolpert, do you have a view on that?
Yes, I do. I think I'm with Steve, but with one slight addition, and that is I think scientists do have a responsibility to explain as clearly as possible to the public the implications of their work, because a lot of it's technical, people don't understand what it's about, and I think it's up to them, particularly where there are social implications, to make those implications as clear as possible.
Nora O'Neill, do you feel, looking from the outside, that the scientists are actually fulfilling that responsibility that Lewis Wolpert says is upon them, to explain what they're doing? Not necessarily to have specific responsibility for the knowledge, but to explain it.
Well, I think Steve Jones has done admirably in that respect.
What about the rest?
There's a great deal I don't understand and on the other hand, in this case, there's something we all do understand, which is the question about the control of information. And we read constantly about the best guarded information in the world, whether it's commercial secrets or military secrets, being available and becoming available to people to whom it should not be available. That's what hackers do, and they get into the Pentagon computers. It seems to me that when we think about the control of access to genetic information about individuals, we have to take very seriously that we don't have infallible systems of controlling access to information. We have to make them as good as possible to protect people from the wrong sorts of access.
Final comment on this issue, John Maynell-Smith?
Well, I really have sort of two things to say. I mean, first of all, I think it's good news if one understands the genetic basis of some particular disease, because it's the first step to curing it. I mean, I'd be deeply happy to know that some serious disease was genetic and how it was genetic, because I would hope that in 10 years people with it could be cured. But there is one other thing that's come up in the discussion in the last 5 minutes that slightly worries me. I'm all for concealing from the insurance company what is wrong with me. I would be exceedingly worried if I thought my doctor was concealing from me what was wrong with me. I think when I was young, doctors lied to patients as a matter of course because they thought we weren't old enough to know. I'm happy to say nowadays that I believe my doctor does not lie to me on important matters, and I hope they will continue to tell patients the truth and not assume we're too young to know.
Let's go to another caller now. Sandra Ward from Leicester. Good evening, Sandra Ward. What is it you want to say?
Well, as I understand it, the genome is the alphabet and the schematic numerals of our being. And my concern is that as far as I can tell, from what I understand, that is only the beginning. It's not the language. I mean, and if you understand the alphabet, you don't understand all about an English person if we're talking about the English language.
So you're saying that to reduce human beings to this long sequence of letters, this code, somehow what does them a disservice, or is it you're saying to pretend that you understand them if you know the code is to deceive yourself?
I think so, yes, because there is this spiritual aspect to a being, and as I understand it, to learn the alphabet is just the beginning, because then you have to know what words are in that language.
Right, let's see what Steve Jones makes of that. I mean, perhaps some people would say that there's a degree of hubris going on here, that you are attempting to understand something and, failing inevitably in doing so and deluding yourself that you have understood it, that you are leaving out whole aspects of human life, such as spirituality.
Well, I mean, to trivialise it, perhaps not to trivialise it, I worked for longer than I would like to admit on the genetics of snails, and I think it's fair to say, I can think one person will be annoyed if I say this, but to hell with him, he's not listening anyway. I know more about the genetics of snails than anybody else in the world. I still have no idea what's going on in the genetics of snails. I don't believe, and I think I'm right in saying, that snails have any spirituality. So, if we know nothing about what's going on in the genetics of humans, we're not even beginning to approach the idea of whether we have a spirituality which is above the genes we possess. So I plead, and I think geneticists should plead, invincible ignorance. What we know is trivial. The spiritual and moral issues are above what we're doing, and they're separate issues, and they don't yet impinge on each other. Some people do feel, I think, Lewis Wolpert, perhaps you have a view on this, some people do feel that somehow if you know an awful lot about the way that life works, you in some way diminish its mystery. There's less awe for it. If
Do you
No, I
share
think
that
it
view?
actually fills one with awe.
Yeah, I'm glad you said that's what I was hoping you would say.
I have to say that I'm an embryologist and I'm a developmental biologist, and for me, genes, I look at them in a totally different way. They provide a set of instructions. The main function of genes is to provide a set of instructions for the embryo to develop. And perhaps we embryologists are more arrogant than geneticists. That's probably true.
I've noticed.
And I think that we're beginning to understand how the genes, well, just at the beginning. I mean, we have the illusion of understanding at the moment, that we're beginning to understand how genes control development. And I don't think spirituality really comes into it in that sense. Where spirituality comes in is that when you've got a human being, they may have spiritual feelings, but that's something quite different.
Laura O'Neill, speaking as someone who is interested but outside of science, does it disturb you at all that as the scientists know more and more, so there is a sense of loss of awe, which both Lewis Walbert and I have said we don't actually feel, but I know that many people outside science do feel that we are diminishing the universe the more we attempt to understand it. The fact that we can write a book about it somehow limits it and takes away the sense of awe.
No, I have no feeling of that sort. I think that
That's
the
very
more
encouraging.
questions we ask and the more we answer, the more we realize the further arrays of questions that we can't yet answer, and that we learn in a very clear, evident way how limited human knowledge is. So I neither have a sense that there's nothing left to be discovered, let alone a sense that we understand everything about human beings. There's room for all the things that the caller's talking about, and a lot more besides, I would guess.
John Maynard Smith?
I mean, I've been a sort of a naturalist since I was a kid. I mean, I adore looking at birds and flowers and things like that. But in no way has my sense of awe at these things been reduced by the fact I know something about their genes. And certainly my sense of awe at human beings has not been. I think the more you know, the more wonderful the world is.
I always, the example I always come back to on this question of knowing a lot and feeling a sense of awe is one particular chemical company produces a chart, which I'm sure everyone around the table has seen, showing virtually all these the chemical reactions going on inside a single cell, and not just once, but a myriad times over inside that cell. And when you look at the sheer complexity of it, there is a sense of marvel to look at it and think, all this is going on. How can it possibly diminish one's respect or fascination to understand this?
Well, yes, except I once went to 24 lectures that went through the whole bloody lot of them.
That's Steve. That's Steve Jones. That is a beautiful note to bring us down. And so it is all we have time for. All I can do is offer my thanks to Professors Nora O'Neill, John Maynard Smith, and Lewis Walbert, and of course to the 1991 Reith lecturer, Dr. Steve Jones. From all of us here, good night.